All right, for this, this was the next thing that we didn't really get to because of the internet issues, but talking about radians. So radians is another form of measurement when we're dealing with angles. We're probably most used to degrees. So radians is just to give you a definition. One radian is the arc length that subtends the angle, which is the same distance as the radius. So, okay, that's great. What does that mean? So if you've got a unit circle here, and we've got um, an angle that's created, let's go here. We've got a radius, and then if we've got another radius. So normally, we would call this theta, and then this arc here, so I'm going to highlight it. So this arc would have a degree measure equal to theta, right? That's something that we learned in geometry. But if you're looking at trying to measure that in radians, it's in a measurement system that says, well, how many radii does that equal? If I were to take my radius and I were to bend it over the circle, how many radians would that be? So to get you to think about this based on things that we've seen before, we know there's some facts that we know about circles. We know that the circumference, well, let's start with this. A full 360 degrees. So if I start at one point of a circle and I walk the perimeter, I've walked 360 degrees. That's that angle. A full rotation is one full rotation is 360 degrees. Now, if I want to get this in measurements relating to my radius, we got to think about some other circle geometry. And so in radians, my circumference, a full rotation, is 2 pi r, right? That's an equation that I hope we have back in our memories. But if we're dealing with a unit circle, our radius is just equal to 1. So what that tells us is that a full rotation, one full rotation in radians is 2 pi. And so we're just going to leave pi written as is. We're not going to round. We're going to keep it written in its exact form since pi is an irrational number. So I now have this relationship between degrees and radians. And what it tells me is that one full rotation can either be 360 degrees or 2 pi radians. And so that gives us what's called a conversion factor. Just like you can convert inches and centimeters, we can convert degrees and radians. So for every 2 pi radians, there are 360 degrees. So let's take a look at some examples of how we can utilize that. All right, we just answered those 3 questions. Great. So let's do a little conversion here. I'm gonna just copy this, and we're going to move it to here. All right. So if I wanted to take an angle measure that's written in radians and change it to degrees, so if I have pi over 3 radians, I can use the fact that I've got 360 degrees for every 2 pi radians. And then I can multiply these out. So if I've got 2 pi radians. So what happens is, in my numerator, I'm going to get pi over 3 times 360. I'm going to write this all out just for the sake of it, and then you'll get used to how this happens. And then in my denominator, I have 2 pi radians. And then you can begin to simplify. Since I have radians in my numerator and my denominator, those are going to go away because I've just converted. pi in my numerator, pi in my denominator. 360 divided by 3 is 120. So those can go away. And then I've got 120 divided by 2, which is 60. So what I see is that pi over 3 is the same thing as 60 degrees. So I can do that same thing with any radian measure. So if I have negative 2 pi over 2, I'm going to convert it. And then I'm going to simplify. So you could, since these are fractions, go like this. Over 2 times 2 pi. And then we could simplify from here. Pi, 360 divided by 2 is 180. 180 divided by 2 is 90. So I get negative 90 degrees. So I see that negative pi over 2 is the same as negative 90 degrees. Remember that negative just means we go counterclockwise. And so we can use the same conversion factor to go from degrees to radians. So let's go from degrees to radians. So if I'm dealing with this first one that says 30 degrees. So if I want to go from 30 degrees, I want my degrees on the denominator now because I want to end up with radians. So I'm going to get 30 times 2 pi. 30 degrees times 2 pi over 360 degrees. You'll notice that I'm going to cancel out degrees and degrees. And then from here, I can simplify 10 and 10. Take out a 3, take out a 3, I'm left with 12. And then 2 divided by 12 is going to leave me with a 6 in the denominator. So I see that I'm going to be left with pi over 6. So 30 degrees is the same as pi over 6 radians. All right, and then let's do this last one, 45 degrees to radians. Let's go back to green. And this time I'm not going to write it out, all of the measures. So what's going to happen here is 45 times 2 pi is going to give me 90 pi on top over 360. And then I can start to cancel out and simplify this fraction. Cancel, cancel. Take out a 9. I'm left with a 4 in the bottom. And so I see that 45 is the same as pi over 4 radians. And that is what an intro to radians and how to convert between degrees and radians and degrees.